Hello and welcome to another one of these ADD videos. Today we're going to be looking at an introduction to organic chemistry. This consists mainly of a review of Gen Chem topics that you should be familiar with in order to properly grasp what's going on in OChem. Any of these topics that you are uncomfortable with after I go through them, please go through in greater detail at your own leisure. This handout here can be found on dallaseducation.org, and I am going to go through it in a couple videos, maybe 3, depending on how long each one takes. So let's begin. What is organic chemistry? Organic chemistry is the study of the chemistry of carbon-containing compounds. And carbon will form strong bonds with other carbon or wide variety of other chemicals or elements. And all these carbon-containing compounds form the basis for life on Earth. So, where did this all begin? Well, in around 1830, there was a scientist that created urea from heating ammonium cyanide in an anaerobic environment, no oxygen. And from there we went from an inorganic compound to an organic compound, and that's dubbed as the beginning of organic chemistry. So when we're looking at chemistry, we need to be very familiar with, of course, the atom. Atoms are the building blocks of everything we find, and they're made up of protons and neutrons found in the nucleus, and then electrons that are found in concentric shells, meaning one spherical shell, then there's a node, and then another spherical shell. We'll go through that here in a little bit. But the charges for a proton is positive, then for a neutron has no charge, and an electron is negatively charged. And the mass of these two guys, the protons and the neutrons, is roughly 2,000 times greater than that of an electron. All right? So how do we identify the elements? Well, all atoms of a specific element will have the same number of protons, and this is called the atomic number, and this is what allows us to differentiate all of our elements on this wonderful thing called the periodic table. As you can notice here, we have 1 proton, 2 protons, 3, 4, 5, so forth and so on. Okay? So, what is an isotope? Well, isotopes are atoms that have the same number of protons but differ in the number of neutrons. Okay? And again, if any of this is not coming back to you, please feel free to go back and review your Gen Chem notes. Or you can check out my videos in Gen Chem. So, we've already discussed that the electrons are a lot lighter than the protons and neutrons that are found in the nucleus, and they behave more like waves than particles. And basically, they're bound by the attractive force of the protons in the nucleus, and they just go around in these spherical shells, and you can think of them as a probability of finding these electrons in any spot on that shell. Okay, it's impossible to know the exact location and the speed of the electron because of Heisenberg's uncertainty principle. But basically, we have these what are called probability densities. So this is a electron density map that shows you the probability of finding the electrons within this compound. Red would be the highest probability, yellow less, green even less, and then blue would be the least. Here we're going to have an organization of the periodic table that's based on quantum numbers, and each quantum number is a different row on this periodic table. So each one of these rows consists of a quantum number which represents we're going to have a shell, then a node, then another shell, then a node, then a shell, so forth and so on. And then within those, we have orbitals in which the electrons travel. Okay? So the s orbitals are going to be these first two columns right there. And basically, we have the p orbitals here, we have the d orbitals, okay, f. All right, so the s orbitals are spherically shaped. And we just talked about the quantum numbers. The p orbitals are shaped like dumbbells, and they're on the XYZ axes. Okay. And the nodal plane is somewhere, or is right in between the two lobes. So electron density has to talk about, or has to deal with the probability, like I showed you earlier on that red and blue-green picture. And the electron density has to do with probability of finding an electron in a given spot. So because the Pauli exclusion principle tells us that we can only have 2 electrons in any given orbital, their spins have to be paired. Off-bow tells us that we start on the lowest energy shells and then go up. So we start with S, then we fill the P, and so forth. And then Hund's rule tells us that if we're looking at, let's say for instance, the p orbitals, okay, so we have the s, and we're going to have 1 there, and then p, and then we have 3 of those guys. Each of those can have 2 orbitals, or 2 electrons, sorry. So let's say we fill our s up, and now we need to fill the p up, okay? So the p filling up would be like this. First you would need to do 3 of them like that, and then you would have pairing. That's Hund's rule, okay? Filling up the s, then the p, that's off-bow. Filling up p individually, then pairing up, that's Hund's, okay? So brief recap, atoms have their nucleus, protons, and neutrons. Protons normally would repel each other, but the neutrons buffer the repulsive forces of the protons. Electrons orbit the nucleus in spherical shells. Each one of the rows of the periodic table has to do with a shell, corresponds to a shell. The number of protons is what identifies the atoms belonging to a specific element, and that's an atomic number. And unless it's an ion, it's also the number of electrons. To get the number of neutrons, you take what's called the mass number, and you end up subtracting the number of protons from that mass number. Remember, the atomic mass and the atomic number are not the same thing. Only for carbon-12 is that true. Isotopes have the same number of protons but different number of neutrons. Orbitals are the different things on the periodic table, so the paths that the electron takes within those shells. So there's the S, the P, the D, the F. All right, and then the shapes. We'll go into this a little bit more when we discuss the bonding and the Vesper theory stuff, okay? So I hope I've reviewed you enough on your Gen Chem to feel confident in your introduction to OChem. Part 2 will deal with bonding, and we were going to look at some of the trends that you might find on the periodic table here. We note that there are many things such as electronegativity and atomic radius and all these things that happen to have a pattern that increase in a certain direction and decrease in the other direction. We'll go through all of that and what the properties are on part 2 of the video. Thank you and have a nice day.